Alright, so last time we did area under two functions where one function was obviously bigger than the other function over an interval. Today's lesson is going to be similar to that, except for we're going to look at an area that's completely enclosed by two functions that intersect at most twice. And really, for all of our examples, they're going to intersect exactly twice. And so that's sort of the new part, right? They're going to intersect. And so I'm going to go through an example. So it's going to be very similar to what we did last time. The new part is that I have to find where the two values intersect. All right, so the first step, which is the new step from what we did last time, is find where my function f of x is equal to my function g of x, right? This is where they intersect. All right, and so I'm going to look at an example. And all of our examples will intersect twice. So we're going to find an a value and a b value where our values intersect. And so I'm going to do this one by hand, and then the next couple of examples after this, I'm going to do it with the calculator. If you graph these two functions, right, so if you plug them into the calculator and graph, the graph comes out where they do intersect twice. And so I wanted to graph it just to kind of show you what the area looks like when I'm talking about being completely enclosed by. All right, so that would be the g of x, which is x squared. And then that's my f of x, which is 2x minus x squared. And so this is the area we're finding, right? The area completely enclosed by, meaning completely surrounded by my two functions, which is different than the last examples. The last example we're bounded by upper function and lower function, but then there was also edges that came from our x values that were given. So this one doesn't have those edges. What they do have is where my functions intersect. So these would be my a's and my b's that I'm looking for. So those are the values we want to solve for. When does my function g of x intersect my function f of x, which is when they're equal. All right, and so I'll find that. And so like I said, we're going to do them graphically in the next couple of examples. So this one I'm going to solve by hand. All right, so I'm going to solve this algebraically. Maybe I'll solve it algebraically. All right, what we call by hand or using the algebra method. All right, which means I'm literally going to take f of x, set it equal to g of x, and solve for the x values. All right, so my f of x was 2x minus x squared. G of x was x squared, right? It's a quadratic, so that's the square part, so set it equal to 0 in order to solve. So I'm going to move this x squared over to the other side. And so I'm going to get 2x minus 2x squared equals 0, and then I'm going to factor. All right, most of ours are factorable. If they're not factorable, then you have to use the quadratic formula or graph it and find its zeros. All right, all of ours, though, should come to fairly nice numbers, should factor. All right, this one I can factor out a 2 and an x. When I factor out a 2 and x in the first term, I'm left with 1. In the second term, I'm left with a negative x set equal to 0, and that means I've got a factor at 0 and a factor at 1. And so there are my a and b values. So that means, when I put b and b instead of a and b, all right, so I know this value, excuse me, all right, this value is at 0, all right, so that's my a value. And I know this value is at 1, so they intersect at 0 and 1. And so my area is between f of x and g of x, right? It's between f of x and g of x over the interval 0 to 1. And so that's what I want to find. Excuse me. Excuse me, guys. All right, and so there's the first step, all right, that's the new step, right? All the rest of the steps that we're going to go through are similar to what we did in the last set of notes. All right, the second step is I have to figure out which function's bigger because it matters how I subtract. All right, there's two ways to do it. You could just look at the graph, and if I look at the graph here, this is my f of x, and this is my g of x. So f is bigger than g over the area that I'm looking at. All right, so looking at my graph, I look at my graph, f of x is larger than g of x over the interval 0 to 1. But if I don't have my graph, I can still figure out, or if I'm unsure about my graph, I can always test a point. All right, so that's what I'm doing. I'm going to test a point, and it's got to be a point inside my interval. 0 and 1, there's only fractions, so the easiest one to test would be 1/2. All right, 1/2 is the x value I'm going to test. I'm going to find f of 1/2, and g of 1/2. All right, so f of 1/2 is 2 times 1/2 minus 1/2 squared, which comes out 0.75, or 3/4 if you prefer. All right, well, test g of x, and based on up here, and it should come out smaller, and this is my test to make sure that it does. All right, so I'm plugging 1/2 into my g function, so it's going to be 1/2 squared, which is 1/4, or 0.25, and so it checks. F is bigger than g. All right, so I'm checking it. So that's my second step, which function's bigger, because it matters when I set up the integral. All right, I've got to always subtract the bigger function from the smaller function. So if f is the bigger function, this is the integral I use to find my area. If g is the bigger function, this is the integral I use to find my area. Well, in our example, f was greater than g. And so when we set up the integral to find my area, I'm integrating over the integral 0 to 1. And I'm going to take f of x and subtract g of x. Right now I'm actually going to type that out, so I'm going to do that in my next step. All right, so solve the integral, show the antiderivative, and if you need to, you can check on the calculator. Area should always be coming out positive, never negative. If it comes out negative, it probably means there's something wrong with your subtraction step. All right, so now I'm going to solve it. So I'm going to set up my area function 0 to 1. F of x was my bigger function, which was 2x minus x squared, minus g of x, which is just x squared. I'm going to simplify that because it's easier to plug it into the calculator and solve. So 2x minus 2x squared with respect to x. And I'm going to solve this one completely by hand. All right, so I'm going to solve it by hand, and then I will go and check it on the calculator. All right, so first find the general antiderivative, which would be 2x squared divided by 2 minus 2x cubed divided by 3. And this one's actually not too bad by hand, right? Because when I plug 1 in, the 2's will reduce and give me 1 minus 2/3. And then when I plug 0 in, it just zeroes away. And so 1 minus 2/3 means my area is equal to 1/3. All right, so the area in between my two functions, if I go back and look, that area, it's a little bitty area, it should make sense, it's going to come out small, is 1/2, 1/3. Alright, that's what that area looks like. And again, like I said, you could solve your integration and check on the calculator. I'll leave the check on the calculator for you to do. Alright, the next two examples we will be, so that was an example by hand, alright, which you can always solve these by hand if you want to. The next two examples I'm going to solve completely on the calculator, alright, because most students prefer the calculator method, but it's up to you. You could also solve them by hand. Alright, if you are going to solve them on the calculator, what I want to see is the definite integral that gives me my area correctly, and, you know, simplify it with correct notation and then solve to find my area, and then you can solve on the calculator. But I do want to see the picture. Right, the graphs that you're using. So you're solving this graphically. You need to show me the pictures. All right, so I know that's how you're solving them. All right, so this first example, I'm going to solve it graphically. All right, so step 1, graph both functions. All right, so I'm going to graph both functions. I'm going to plug them into the calculator. So I've got negative x squared plus 10x minus 8, and then negative 5x plus 28. And because of that, I know my window's got to be bigger than a 10 by 10. Alright, so I'm going to go into window. Actually, the window I have here, I think, is one I checked out earlier. So do make your window a little bigger, and I just had to play around with it to get it. And so I left my x minimum negative 15, my x max 15. My y minimum negative 40, and my y and again, in order to get this window, I had to play around with it a little bit. All right, I had to zoom in, zoom out, and kind of play around with the numbers, but it should give me a fairly decent looking picture where I can see the area and the 2 points where we're intersecting. All right, so I'm going to go hit my graph. All right, there it is, and I want to find those 2 moments. All right, and so remember, we did this before. The intersection on the calculator, you go hit second trace, pick 5. first curve, second curve, and guess. So I'm just going to do one of them. I'm going to leave the other one if you want to practice for you to do. All right, first curve, second curve, and guess. So again, you have to get your cursor as close as you can to that moment, and then as long as it's close, you can hit your button 3 times as long as it doesn't go too far away and it looks like it's staying pretty close. All right, so they intersect at this first moment at 3, and if you do the same thing over here, this point is 12. All right, so again, do the same thing, second trace, and 12. And I want to see the graph. If you're solving this graphically, I want to see it. And so when you go write your answer and you solved it graphically, I want to see your graph. All right, so this is what I want to see. All right, so they intersected up here at 3 and down here at 12. Oops, hit my button on my thing. Alright. Alright, it's a funky straight line, but it's supposed to be a straight line. Alright, so there's f of x, which is the line. There's g of x, which is the parabola. They intersect at 12 and 3. Alright, and so this is the area I want to find. And so I want to see this. If you solve it graphically, I want to see the graph. If you solve it algebraically, I want to see your algebra. Alright, so if you, again, this is the work. So you need to show me. If you're solving it graphically, show me the graph. If you're solving like we did in the last example where I set them equal to 0 and then factored, you have to show me that. But you don't have to do both. You pick one. But make sure, again, you show me the work. Alright, the second step. So I know the area between f of x and g of x is found over the interval 3 to 12. My area is between 3 and 12 in my two functions. And then which one's bigger? Well, this is the g of x, this is the f of x, and it's the y values. The y values are bigger on this side than they are on this side. So g of x is larger than f of x. And if you're unsure, you could always pick a test point, test it and see. All right, but g of x is bigger than f of x. All right, that means when I go find my area, I'm going to integrate from 3 to 12, I'm going to take the g of x and subtract the f of x. So g of x was negative x squared plus 10x minus 8, and I'm going to subtract, and you need parentheses, f of x, which is negative 5x plus 28. All right, and then simplify it, all right, before you go to solve it. All right, so negative, make sure you're careful. This negative would distribute, and I'm just going to do the subtraction kind of in my head. Negative x squared, well, there's no square term here, so that just comes along. 10x minus a negative 5, well, that means I'm going to add the 5x. And then negative 8 minus 28, so negative 8 minus 28 is going to give me a negative 36. All right, and again, it's up to you. If you solve it by hand, I want to see the general antiderivative. I want to see the value at 12 and I want to see the value at 3. If you solve it graphically, which I'm going to assume most of you are going to solve this area graphically, alright, I want to see the picture, which means I'm going to go through and solve it graphically. I have to regraph, so I need to get rid of those. And then type in the new function, which was negative x squared plus 15x minus 36. I think the picture I had up there before, or the window I had up there before, should be fine. I forgot my negative. Negative x squared and there it goes. So there's my picture. All right, and again, it looks like it should intersect at 3 and 12, and so when I go graph it, it's that area above on my integration. My lower limit's 3, my upper limit's 12, and then it finds that area between 3 and 12, and that's the way it usually looks, especially when we're dealing with parabolas. All right, and so that area is 121.5, and again, you need to show me that's how you solved it. All right, so we solved it graphically. All right, so you need to show me the graph. All Alright, and that's the area we found, which was 121.5, which again, we did draw a new function, but this area that we found, the 21.5, is exactly the same as this area. Alright, remember that's what the theorem that we talked about last time does. Alright, and they're solving it completely by hand, or sorry, with the calculator. And so I'm going to do a second example on the calculator. Again, if you want to solve it by hand like we did the first example, feel free. Alright, so there's our second example using the graphing calculator. Alright, so again, first thing you do is graph these and show that that's how you're solving it. So we got to go into our calculator, clear out anything that's in here, type in our two functions. So we've got negative x squared plus 10. Oops, I'm looking at the wrong one. That was the previous one. Sorry, it should be positive x squared plus 8x minus 10. That's our f of x function, and then our g of x, which is negative x squared plus 10x plus 14. I might go to a standard window, start there. So window, zoom, standard. Let's see if I get, so I need to go a little bigger. So it looks like I'm above and below. So this is again what I meant by before, we play around with it. So I might leave my x values fine, because those look like they're okay. But I might go down to negative 30 and up to positive 30 and see if that gives me a better looking window. There's my first function. Alright, so I'm fine below. I can see that one. So I still need to go up a little higher. So I'm going to go up in my y direction. I'm going to go up to 40. There's my first. Alright, now I can see it. Now you might want to go up a little more if you want to, but I can see my two areas. Alright, so there's the area I want. I'm going to find my intersect. So again, second trace. I'm only going to find one of them, and again, you do it the same way for both. I'm going to find this one up here. So get as close as you can to that moment. First curve, second curve, guess. And so my x value is 4. Alright, so then you show the graph, right? Show what your work. If you're solving it by hand, you would show the algebra where you set it equal to 0 and factor. Well, if you're solving it with the calculator, you're going to show, again, your calculator work. Oops, wonky picture. Alright, and so we found those two moments. That was at 4. We found that one, and if you go in and you do the same thing before, this one's found at negative 3. Alright, so this is the area we're looking for. Alright, the parabola opening down is g of x. The parabola opening up is f of x, right? I look at my first x squared, they tell me how it's opening. And so if I look at my picture, g of x is the bigger function, right? G of x is larger than f of x. So I'm going to find my area between f of x and g of x over the interval negative 3 to 4. And an easy way to check on this one is 0. If you plug 0 in, if I plug 0 into g, I get positive 14 out. If I plug 0 into f, I get negative 10. 14 is obviously bigger than 10. So it's really easy to check to make sure that's the case. Alright, we're going to integrate from negative 3 to 4. I take my bigger function, which was the g. Subtract away my littler function, which was the f. Alright, and then simplify it. I want to see, at the very least, it's simplified. Alright, make sure you're careful with the negative. It distributes. Again, I'm going to do it in my head. I'm going to subtract. Negative x squared minus x squared is going to give me a negative 2x squared. 10x minus 8x is going to give me a negative 2x. 14 minus a negative 10 really means 14 plus 10. And so that comes out positive 24. And there's the new function, which I can now solve using the fundamental theorem of calculus. So again, it's up to you. If you want to solve it by hand, you'd find the general antiderivative, plug 4 in, and plug negative 3 in, and subtract. I'm going to assume most of you is going to solve it graphically, and so you're going to go ahead and you're going to graph it and solve it that way. And again, I'm going to walk you through it. All right, so type in the new function, right? The negative 2x squared plus 2x plus 24. Graph. There's my new function. I'm going to graph it between negative 3 and 4, which is where it should be hitting the axes. So second trace, 7, negative 3, enter, positive 4, enter, and it should shade that in, and so it's 114 1/3. So area comes out 114 with 3 repeating, or 114 1/3. And again, if you solved it by hand, you'd show me that work. If you solve it on the calculator, you also need to show me the work, and the work is just show me what you got on the calculator. All right, so that was negative 3, 4. That was my area, and we solved. And so there's the answer. The area between my two functions is 114 1/3. Again, we use this area, but remember, it's exactly the same as this area. All right, and so that's area between two functions, and we're going to do an application of that eventually in 5.1, which is an important type of application called consumer surplus, producer surplus. All right, and so that finishes up this section. All right, so make sure you practice this, practice typing it in, practice it solving it, and try one by hand, and then make sure you practice it both ways. All right, we'll stop there.